So we're going to look at section 2.8. And first off, we're going to look at the distance formula. So the distance formula, say we have 2 points. There we go. Now we want to find the distance between those 2 points. So some distance d. Now, a trick we can use is we can turn this into a right triangle. And let's find the base and height of this triangle. Well, the base, we're going from x1 to x2. So this is the base. Now for the height, we go from here at y1 up to here, y2. And this distance, well, it's y2 minus y1. Maybe I can do this a little bit differently. Like so. So we have the base, we have the height, base and height. We can use the Pythagorean theorem to put all this together. We've got our triangle. So according to the Pythagorean theorem, d squared is base squared plus height squared. Now, we know what the base is. And we can solve for d by taking the square root. And so this is our distance formula. And, well, let's put it to use. So let's say we have a couple points here. Let's see. Five and 1 and 8 and 5. Well, we're just going to plug these into the distance formula. Now, I recommend labeling the coordinates. Here's our first point. And there's our second point. And we just plug them in. And there's our answer. It's going to be 5. And when we took the square root, we kept the positive root. The reason is we usually consider distance as a positive number, not a negative number. So there we go, positive 5. Now let's look at the midpoint formula. So suppose again we have 2 points. And we've got some distance between them. A midpoint, now this is the shortest distance between these points. We're not sort of arching out to get there. Not doing anything like that, just directly there. So in the middle, along this distance, there's a point xm, ym. That should be close. And the idea is that this distance is equal to that distance. So let's take a look. Now for this first distance, we'll let xm, ym play the role of x2, y2. And that'll be equal to this distance here. And we're going to let this, so this is the distance we've got right here. This distance, we're going to let xm, ym play the role of x1, y1 in our formula. And we can square both sides here. And so what we're going to get and there we go. Xm minus x1 squared plus ym minus y1 squared equals x2 minus xm squared plus y2 minus ym squared. So each of these squared parts, these squared terms, we've got to expand. We can FOIL it out. And so what we're going to get. We'll get this when we FOIL this one out. If we FOIL this, well, we're going to get that. Now we can expand this or FOIL it. And then the same here. Now we can do some cancellations. Above the equal sign, we have an xm squared. And then below this equal sign, there's an xm squared. We can subtract xm squared from both sides, canceling those out. We also have a ym squared above the equal sign and a ym squared below the equal sign. Subtract from both sides, they're going to cancel out. So this is what we get. All right. So we're gonna kind of do a little trick here. We've got terms that are just, well, an x squared or a y squared. And then we have terms like an x sub m or a y sub m in them. So I'm going to put all the terms that have a y sub m or an x sub m on one side of the equal sign and move over the terms without an x sub m or without a y sub m, move those to the other side, opposite side. So I'm going to add to xm x1, add to ym y1. And on this side, I'm going to subtract x squared 2, subtract y squared 2. Double check my arithmetic here real quick. Make sure I copy this down right. All right. So what we can do these are difference of squares. So we can rewrite this as x1 minus x2, x1 plus x2, plus y1 minus y2 times y1 plus y2. And then here we can factor out xm and ym. We can factor out a 2 also. And there we go. Now, we want to make these equal. So taking a look at the x's, we have an x1 minus x2, here's an x1 minus x2. And then looking at the y's, y1 minus y2, y1 minus y2, and I forgot there's an equal sign in between here. So this whole part here equals this whole part here. So for these to be equal, we need the x part equal to the x and the y part equal to the y. Now, that's one way we can approach this. So these are equal. That means these two have to be equal. So that means two x sub m, whatever this is, it's got to equal this. So the x parts are going to be equal. Same thing with the y. Y minus y1 minus y2, y1 minus y2, 2ym, but this is a y1 plus y2. These two have to be equal. And so now we can solve for xm and ym, and we're actually going to get what these coordinates are of that midpoint. So divide both sides by 2. Same here, divide both sides by 2. And there's your formula for the midpoint. The midpoint between 2 points, average of the x coordinates, average of the y coordinates. And let's look at an example. Now again, let's go back to those points. 5, 1, and 8, 5. And again, we want to label these, or recommend it, just so we don't mix things up. So if we want to find the midpoint between these 2 points, well, it's going to be this. So we just plug in our x1, y1, x2, y2, and do the math. And we get 13 halves and 3. And that's the midpoint between those 2 points. All right. So that's the distance formula, and that's the midpoint formula. Now I want to talk about what a circle is. When we think of a circle, we typically think of something like this. And we're going to be interested in a center. And let's give that center some coordinates here. Call this H and K. And circles have a radius. It's a distance from the center to any point on the outside or on the circumference of the circle. Well, the outside of the circle. And the edge of the circle, I should say. Circumference is the measure around the circle. Anyway, a proper definition of a circle is this. So a circle is center HK and radius R is a set of points. It's all the points, set of all the points that are a distance R from that center. And again, I'll just mention it, center HK. So that's all that it is. It's all the points that are a distance R from that center. So this point would clearly be on the circle. At this point, again, the radius would be here, the distance r from the center, distance r from the center, and barring artistic license, a distance r between these 2 points, the edge of the circle, and again, the center. So that's what a circle is. So there's a few things we ask about circles. First off, we have what's called a standard form of a circle, and we developed this from the distance formula. Remember, the distance formula is d x2 minus x1 squared plus y2 minus y1 squared. So let's say we have a circle. Let's give it a center HK, radius r, and let's say we picked any point, some random point, xy. We're not sure which xy we've picked. We only know this. Whatever point we've picked, it satisfies the requirements of being a point on the circle. That means the distance between this point and the center has to be r. Or in other words, to compute our distance formula, the distance needs to be r, and the distance between the center and whatever this point was we picked. So x2 in this case is just x, x1 is h, y2 is just y, and then y1 is going to be k. And again, let's square both sides. And so what we get is the standard form for the equation or the formula for a circle. Assuming xy is a point somewhere on the circle that has a center of h and k and the radius is r, xy is only going to be a point on this circle if it satisfies what's going on here, this formula. And that's the standard form for our circle. Pardon me, let me get a stronger pen here. Hopefully. So, what kind of questions might we get about this? Well, first off, we might be given some facts about the circle. We need to come up with the formula. So let's suppose we have a circle with a center, let's say 3, -2, and a radius, let's say 5. And we're asked to come up with the standard formula or the standard form of the formula for the circle. So the center is h and k. So there's h, there's k, and there's r. So let's just plug it in. Or x minus 3 squared plus y minus -2 squared equals Well, 5 squared. Subtracting a negative is addition. So we get x minus 3 squared plus y plus 2 squared equals 25. And so there you go. Now there's an interesting thing to notice here. When a coordinate for the center of the circle is positive, you're going to get a subtraction. When the coordinate for the center of the circle is negative, you're going to get an addition. And just something to point out. All right. Let's see. Now, let's say we have something like this. Now let's say we're given the formula for a circle in standard form. Can we find the center? Well, we want to turn this into a form of x minus h and x minus and y minus k. So we can do that by noting that, well, plus can be rewritten as subtracting a negative. So that gives us an x minus, well, some number, an x minus h. And then y minus 4, and then we want to rewrite this as a number squared. Now let's make this a little challenging. Let's say this was, instead of 36, let's say this was the number 2. Say it's 2. Well, this is always equal to r squared. So what we have is r squared equals 2, or r is the square root of 2. And again, we're going to take the positive root because a radius is a measurement, so we're going to keep measurements positive. So we can rewrite r squared as square root of 2 squared, like that. And so that's our r squared. So we can see our x minus h, y minus k, and there's our r being squared. And so what we have is this. The center of the circle hk is -1 and +4. Again, remember, when a coordinate for the center of a circle is negative, you're going to see a plus. The coordinate for the center of a circle is positive, you're going to see a minus. And then our radius is the square root of 2. Remember, this is always x minus h squared plus y minus k squared equals r squared. This is the radius squared, oddly enough. So you have to take the square root of this to just get the plain r. And that's it. Now, lastly, a question that comes up with circles is putting them into standard form when they're, well, they're decidedly not in standard form. And to do this, we have to complete the square. Now, let's sort of revisit completing the square. Let's say we have something like this. And we want to try to solve this by completing the square. Well, what we do is we take the number attached to the variable. This is the variable squared. Here's the variable, just the plain variable. And we also want to make sure there's nothing, well, there's the invisible 1, but there's no other coefficient here. We want to make sure the coefficient is just that invisible 1. Well, it already is. That's great. So we take this number, and we always divide it by 2. Be our first sort of critical number. Then we take that critical number, square it, get our second critical number. So this is what we're going to do. The second critical number, to make this trick work, add it to both sides. And so the way completing the square works is that once we've added this to both sides, we can rewrite this piece, this quadratic expression, in terms of the first critical number. We can simply write this. This whole thing becomes x plus the first critical number. And that's the idea of completing the square. Now, how does that actually work? Well, the idea is this. We'll do a little bit of abstracts here. If you take x plus, say, capital A, and you FOIL this, x squared plus 2ax plus a squared. So basically what we do, if we can create this artificially, then we can rewrite it as that. And so the way we create it artificially is we take whatever number is attached to the plane variable, divide that number by 2 to get that first critical number. Then we need to make sure we get the second critical number by squaring. And so usually the situation that we run into, basically what just happened, is we would have a situation like this. Equals, oh, who knows, 7. Say it's 7. So to complete the square, to get this, so we get that, 2a divided by 2 is a, square that a, add a squared to both sides, and so we get x squared plus 2ax plus a squared is 7 plus a squared. And then now we can rewrite this as that, because this is the same as that. And there we go, we completed our square. So what we're going to do is we're going to use this completing the square to come up with the standard form for these circles. So let's say we have something like this. So let's do a little rearranging. X squared plus 6x plus y squared plus 2y plus 6 equals 0. So let's complete the square for x. So the number attached to the plane variable, not the squared variable, well, it's 6. So we take 6, divide by 2, we get our first critical number, happens to be 3. Take 3, square it, you get the second critical number is 9. This is the number we add to both sides. This is the number we're going to write in our completed square. Let's take a look at this. The number attached to the plane variable is 2. So again, we always divide by 2. Divide by 2, divide by 2. get our first critical number. And then 1 squared, well, that's our second critical number, well, happens to be 1. So again, what we're going to add to both sides, and this is going to be written in the complete square. So let's do those additions. Let's add this to both sides of our equation, add this to both sides of our equation. And so this is what we get. Now, if we complete the square here, this will be x plus 3 squared plus y plus 1 squared. And I don't want to forget, I'm sorry, I forgot to put this in here. On the other side of the equation, we have a plus 9 and a plus 1. I want to make sure I've added 9 to both sides and 1 to both sides. And so what we get is 10. 9 plus 1 plus 0 is 10. Now we can subtract 6 from both sides. So you get x plus 3 squared plus y plus 1 squared equals 4. So remember, the number here is r squared. So this means r squared is equal to 4, or r equals 2. Now this is actually what we're looking for. That is the formula for the circle in standard form. So, but what we can learn from this, since r is 2, this means the radius of the circle is 2. And what about the center? Well, remember, if you have an addition in your formula, that means you'll have a negative in your coordinate. So the center will be -3, -1. And that's it. So if you have any questions, let me know. Other than that, have a wonderful evening.